4.6 Part 3 talks about the composition of trig and inverse trig functions. So remember, composition is where we plug one equation into another, or one function, into another function. So like we did it when we had like f of g of x, or we could have done g of f of x. And so we would have rewritten this as like this. And so it's where we're just taking one function and we're plugging it into another. But it's also like when we did f composed of g, I'm just using the second way I wrote it, of like maybe a 4, and where we worked the inside and got an answer, and then we plug that into the outside function. So just real quick, this has nothing, well, I'm not going to say it has nothing to do with what we're about to go over, but there's no example on there. So like if I told you that f of x is equal to x plus 4, and I told you g of x was equal to 2x. And if we were looking for f of g of 4, so I'll just use the same one I just did there. So the first thing we would do is we would go find g of 4. So we would work this out. So we would say g of 4 was equal to 2 times 4, which would give us 8. And then we would take that answer and we'd plug into our f function. So this would mean we're looking for f of 8. And so then I would take the f function and I would plug 8 into it. So that would be 8 plus 4, and we would have got 12 as our final answer. So when we're dealing with the composition of the trig and the inverse trig functions, we're kind of doing the same thing. All right, so let's look at the table that they gave us there. So the formulas for this are that you can see the first one for inverse sine. It says that the sine, or the inverse sine, of sine of x is going to be equal to x. But it has to be, it only works like that if that x value is between negative pi over 2 and positive pi over 2. Okay? So an inverse and the inverse of a function and its inverse will cancel each other out. So basically what's happening is the inverse and the sine are canceling each other out and just leaving us with that x, but that will only work when x is going to be between these two numbers, okay? So we'll do some examples like that. And then the same thing on vice versa. It says we can take the sine of the inverse of sine, and that will also equal x, but that's only, whoops, I'm just going to use our interval notation, when that x value is between negative 1 and 1. And the reason it's doing that is because that is the input, okay? When we do this one, we know that that angle that we're looking at, because it's just sine of an angle, we know that angle has to be between negative pi over 2 and pi over 2. But here when we do this, this is that y value. This is the inverse of it. So this is where we're solving for the range part. So we have to look at the range of the sine function, which was negative 1 to 1. And then it's the same thing with the cosine. So if I have cosine inverse of cosine of x, that will also equal x as long as that x value is between 0 and pi. So because this is cosine inside, x has to be between those two numbers because that's what we restricted the domain to be. And then if we take cosine of the inverse cosine of x, it will equal x only when that x value there is between negative 1 and 1. And then we have tangents. So we have tangent of the inverse tangent of x will equal x when that x value is between negative pi over 2, whoops, no bracket because it's no equal to, so negative pi over 2 to pi over 2, not including them because remember those are going to be those asymptotes. And then we have they wrote one of these wrong. The first one is written wrong. I didn't catch that. Sorry, I copied what they had written down in your notes. The inverse should be over there, just like the ones above it. I wondered why it was different, and I didn't notice it until I went to write down the second one here. All right, so the second one, is the tangent of the inverse of tangent of x will equal x. But because it's the inverse, the x value has to be between negative infinity and infinity, which means it can be any number, right? Yay, that one makes it easy. It's the only one we don't really have to think about. All right, so I'm going to do the examples on a separate set of notes. So if you need to play this one back, then you can do it, and you don't have to go back through all the examples as well.